All right, so let's do an optimization problem. This one's right out of the book. It's 4.7, number 21. So I summarize the information here. We're designing a box with no top. And the volume of the box has to be 10 cubic meters. The length of the base is twice the width. And the material to make the base is $10 per square meter, and the material to make the sides is $6 per square meter. And we want to find the minimum possible cost. Okay, so let me draw a picture. Kind of try to, whoops, that's not going to make a good picture of a box. To draw it at an angle. Okay, well, that was fun. And what do we know about this? We know that the length of the base is twice the width. So maybe I'll call this one X and this one 2X. And then we don't know anything about the height of the box, so maybe I'll call that Y. And this question is definitely, like, part of it is talking about the volume. So let me just write the volume. Of course, the volume is length times width times height. So I do this times this times this. I get 2x squared y. Oh, and I guess, yeah, I might as well already just go ahead and write that equals 10. But maybe by writing down this volume, I'm sure I'm going to use that, but maybe I'm actually getting ahead of myself. What I usually go for first is writing down an equation for the thing that I'm trying to maximize or minimize, which now that I'm reading it carefully, it's the cost. So the cost is, okay, now I have to pay attention to the cost of the materials. What I'm going to do is I'm going to add up the cost of the base plus the cost of the four sides, and recall that there's no top, so there's no cost for the top. So here we go. Let's do the base. So the area of the base would be 2x squared, and that costs $10 per square meter. So there we go. Plus, okay, now if I'm smart, here's how I'll do the sides. The material for the sides costs $6 per square meter. All I have to do is I have to fill in the parentheses with how much area is on the sides. And okay, so there's four sides. The front would be 2x times y. The back would also be 2x times y. So this is the front and the back. The left and the right are both just x times y. But there's two of them. It's the left and the right, so it's 2 times xy. So this is the front and the back. This is the left and the right. Okay, let's clean that up. I get 20x squared plus, let's see, this is 4xy plus 2xy. That would be 6xy times 6, so 36xy. Okay, good. So this is a familiar spot. Where we are right now is that we have the thing that we're trying to maximize or minimize, but it's in terms of two variables. And this is where I would look for some piece of information that would help me solve for one of the variables in terms of the other one. Luckily, since I got a little bit ahead of myself in the beginning, I already wrote down what that piece of information was. So I can use this piece of information to solve for something and plug that in here. And this is where I like to point out that we have options. I could use this to solve for x in terms of y, or I could use it to solve for y in terms of x. And sometimes it pays to think about what are the consequences before I make this decision. Solving for x would be a bit more involved. I mean, it's not to really complain, but if I can make my life easier, then why not do it? Because solving for x, I would have to do the square root, and then that wouldn't be such an issue here, because then I would just square it back anyway. But then that would be a little bit painful here. If I have to replace x with an ugly square root thing, then I start to not like it so much. It might be easier if I solve this one for y. So y would be 10 over 2x squared, and I guess I should have just written 5 over x squared. So then c is 20x squared plus 36 times x times 5 over x squared. 36 times 5 is 180. And instead of writing 180 over x, let me write 180x to the minus 1, because I'm about to do a derivative, and that'll be nicer looking. Okay, so I have, in terms of just one variable, the thing that I'm trying to maximize or minimize. Now what I want to shoot for is one of these number lines for c prime, and that's going to help me find where the maximum is, or sorry, in this case, the minimum. So I'm going to find where c prime is 0 or undefined. I'm going to make my number line. Because I'm looking for a minimum, I expect that number line to look like a minus followed by a plus. Anyway, so c prime would be 40x minus 180x to the minus 2, right? That would be undefined if x was 0, but if we think about the natural problem that we're talking about and some sort of common sense, x isn't going to be 0. X is a positive number. When I make my number line, I'll probably make one of these no-go zones where x is negative. We're not concerned with x equals 0 or x equals negative numbers here. What I should do is set this equal to 0. So what do we get here? So I move this over. Is this really? Yeah, okay. Right, so 40 equals 180 x to the minus 2, whoops, 40x. And then I'll multiply both sides by x squared to get rid of this, so 40x cubed equals 180. So x cubed equals 18 over 4, or 9 halves. So then x would be, I guess, the cube root of 9 halves. And this is another acceptable use of a calculator. That would be about 1.65. So I'm making my number line, and we said that x should be positive, so I'm not going to put anything here. So I'm going to fill in a plus or a minus here and a plus or a minus here. And let me just go ahead and say what we expect, because we're looking for a minimum. I expect this to be a minus and this to be a plus. Sometimes when I'm doing this, I even fill these in before I check. And I always try to remind everybody how dangerous that is, because you might forget to actually check. Maybe I won't do that this time. I'll check it first, but I know what to expect. I know to expect a minus and then a plus. So to check this, I would like a number between 0 and this is 1.65. Why don't I just do 1 here? That should be easy. C prime of 1, if I'm plugging this in, yeah, that's actually really easy, because 1 to any power is just 1. So I get 40 minus 180. I don't even really care what that is. That's clearly a negative number. Just like I was expecting. I said I was expecting a minus followed by a plus. Now let's do C prime of, say, 2. And what's that going to be? That would be 80 minus 180 times a fourth. And I'm thinking, yeah, of course I expect this to be a positive number. 180 over 4 is 45. So this is 80 minus 45, which is a positive number. Right? So this indeed is the value of x corresponding to the minimum cost. And now we want to make sure that we actually answer the question. The question was, find the minimum cost. And this value of x isn't the minimum cost, it's just the value of x that gives you the minimum cost. To find the minimum cost, what I have to do is plug that value of x in to find c. So I need another piece of paper. So all we're doing now is I'm recalling what c of x was. When we got it as a function of x, it was this. So that's 20x squared plus 180 x to the minus 1. And all I need is c of this number. Yeah, this one is so right. This is like 9 halves to the 1/3. So if I square it, that's 9 halves to the 2/3. And if I do it to the minus 1 power, I get 9 halves to the minus 1/3. And this is an exact answer. Let's not worry about trying to simplify it, because this is the final answer. Why don't I just put a $sign on this and call it good? Okay. Last one for today is an antiderivative problem. This is one where I give you the second derivative of f, and then I give you some information about f prime of 0 and f of 0, and your job is to find f of x. So since this is a second derivative, what we need to do is the antiderivative twice. So if I do the antiderivative once, that'll just be f prime, because that takes off one of the derivatives. And remember how this goes. This is like x to the 1, and we use the power rule. So the antiderivative of x to the 1 is 1/2 x to the 2. The antiderivative of just a constant is that constant times x. So derivative of minus 3 is just minus 3x. antiderivative of minus 3 is minus 3x. Antiderivative of e to the x is e to the x, and the 2 just carries down. But I want the most general antiderivative at this point, so when I think I'm done, I'm not done until I write plus c. Okay, now what I should do is try to find c, because I was given information that can help me find c. So f prime of 0, according to the formula that I just did, f prime of 0 would be, let's see, 0 minus 0, 2e to the 0 plus c. And according to the information I have, that's supposed to equal 3. E to the 0 is just 1, so this is just 2, so I'm going to subtract 2, and I'm going to get c equals 1. So f prime of x is, it's this, and c is 1, and I can simplify it just a little bit. X squared minus 3x plus 2x, 2e to the x plus 1. Okay, and that's just f prime. We want to find f, so I need to do another antiderivative. So I'm doing the antiderivative of this, 1/3 x to the third minus 3 times 1/2 x to the 2 plus 2e to the x plus 1 times x plus another constant. And now I do this again. I was given f of 0. According to the formula, f of 0 would be 0 minus 0 plus 2 plus 0 plus d. And according to the information that I have, f of 0 should be 1. So d is negative 1. So finally, f of x is whatever I had, and I can fill in d, and I can simplify it. So 1/3 x cubed minus 3/2 x squared plus 2e to the x plus x minus 1. Okay.